Hi, everybody. So, this is Mrs. Buchanan, and I am going to talk about concentrations of solutions. We're going to talk about molarity and how to calculate molarity. Yes, molarity has to do with moles, so we'll get into that. But what is concentration? Well, we look at things that are concentrated. We see it on packaging and food. So, orange juice would be concentrated, which means it has more orange juice than water. So if something's concentrated, it has more solute than solvent. So there's a problem here, and I'm actually not going to use it because we didn't do this in lab. But I am going to move down. And I'm going to talk about what is a solution. So a solution has two components. It has a solute and a solvent. The solute is the substance being dissolved. And we learned that back in the beginning. So if I have Kool-Aid and water, which you're going to do a Kool-Aid lab this week or a sugar lab, the solute is what's being dissolved. And that is being dissolved by the solvent. That's the substance doing the dissolving. And then when we put those two together, a solution is a homogeneous mixture. And it looks the same throughout. That is what a solution is, if I can spell this here. Okay. So when we talk about, I love my sweet iced tea, sometimes, or just any drink, Kool-Aid. So when we talk about what we're dissolving and what's the solute, the solvent, and the solution, so the solute is the tea. You could also say along here too that it's tea and sugar, because if we have sweet iced tea, we have to have sugar. That's what's getting dissolved. The water is the solvent, and that is what's doing the dissolving, and the solution is your tea and water. That is the solution. So that's pretty simple. What we're going to learn, though, coming up is we're going to learn about concentration and how do we measure concentration in chemistry. Concentration is the measure of the amount of solute in a given amount of solvent or solution. So dilute means it has a very small amount of solute. So you could do an experiment at home. You could take 3 glasses and fill them up with the same volume of water and add 1 drop of food coloring in the first glass, and then drop 5 drops in the second glass, and then double the 5 and make it 10 in the third glass, and you'd be able to see that the actual third glass has is way more concentrated because it has more food coloring per the same amount of liquid. Concentrated means it has a relatively large amount of solute. So the third glass that I just talked about would actually be more concentrated because it would have more food coloring in it than the others. But we can measure that using what we call molarity. Molarity. So it has to do with moles, and molarity is a unit of concentration, and we represent molarity by a big M, a capital M. Molarity is moles over liters. Okay. It has to be over liters. So some of the problems you get will be milliliters. So you always have to convert it to liters. So what is molarity? Moles of solute per liters of solution. So when we're talking about the moles, we're just talking about your moles of solute, what you're actually dissolving. So when you do your Kool-Aid lab or your sugar lab, however you want to make it, your solute will be what is being dissolved. Formula, moles over liters. I also put the triangle over here, which would be very helpful. So if you have molarity, and remember we've done this in class, if you cover up big M is equal to moles divided by liters. If I want to find moles, and the abbreviation for moles is just M, or MOL. If I cover up M to get the moles, I'm going to take molarity times liters. And then if I want to find the liters of a solution, I'm going to take moles over molarity. So those are 3 different ways to use this equation. Okay, I'm going to move to the next slide and we're going to talk about what does that actually mean. So if I have a 1 molar solution, it means I have 1 mole of solute per 1 liter of solution. So it's I'm not going to say anything. But it's just 1 mole. And if we have 2 moles, it means we have twice as much. So it's 2 moles of solute. So 2 moles of what's being dissolved to 1 liter of solution. And then the third one is we have 0.5 molar solution. So that means we have a half a mole in per 1 liter of solution. So think of a 1 liter container. And actually, if we were in class, I don't have them with me, but what I would do is I actually have moles in class. So if you take your mole that you made, or you're thinking about that, if you take your mole and you put it into a 1 liter of solution, that means you have 1 mole per 1 liter. If we have a half a mole, then we'd cut the mole in half. Sounds kind of crude, but we'd take half the mole and put it in 1 liter. And then if we were trying to illustrate 2 moles, we'd put 2 moles in a 1 liter container, and that would be 2 moles per 1 liter. So what does that look like here? Well, so if I'm going to use my colored pen here. And so if I say in a 1 molar solution, I have 10 moles of solute per 1 liter. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 particles. But if I wanted to make a 2 molar solution, I would end up putting 20 in. 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's twice as much in the same volume. And then if we want to make a 5 molar solution, then I would put in 1, 2, 3, 4, put in 5 moles. So it just shows you that this is the most concentrated right here. And this is the least. And you can tell by the number of particles. This drawing will actually help you on the Kool-Aid lab because you will be doing a drawing like this in the Kool-Aid lab. So you can refer back to this when you go to do the Kool-Aid lab. So which solution is more concentrated? Well, it would be the 2 molar because it has more moles of solute. Because more moles of solute. Okay. The next is which is more dilute, the 0.5 molar, and it's because you only have half as many moles compared to the 1 mole. Other examples. So here are some problems that you can use. I would recommend that you refer to the triangle when you're doing this. So there's things to always be aware of. You always need to make sure that your liters, that your volume is in liters, not milliliters. In this problem, it says, what is the molarity when you have 0.5 moles are dissolved in 2 liters? So if I want to find the molarity, remember that's big M, capital M, not big M, 0.5 moles divided by 2 liters. So if I take 0.5 and I divide by 2, I'm going to get a molarity of, it says 0.25, but because of sig figs, I'm just going to say 0.2 molarity with the big M, or you could also write moles per liter. Okay. Next problem, it says, what is the molarity when 1 mole of solute is dissolved in a half a liter? Well, same setup. So go ahead and set it up. Write down, trying to find big M. So 1 mole over 0.5 liters. So 1 divided by 0.5 will give you 2. So it gives you a molarity of 2. So the question, if you're comparing these two, which one's more concentrated, would be number 2, because you have 2 moles compared to 0.2. And then this problem here, how many moles of HCl are in a 300 milliliter 12 molar solution? So now this is a little different because now we're finding moles. And if we go back and use the triangle, go back and refer to that. So if I'm trying to find moles, I'm going to cover up little m. So moles is equal to molarity times liters. And I'll show you the actual units being canceled out here in a minute. So first thing you're going to do is you're going to change milliliters to liters. So you just need to divide by 1,000. So 300 divided by 1,000. And it will give you 0.3 liters. So times 0.3 liters times a molarity of 12. But I'm actually going to write it as moles per liter. So cross it out. And if you take 0.3 times 12, that will give you 0.3 times 12 will give you, sorry, I can't see, 3.6, and it will give you 3.6 moles. Now, because of sig figs, it will be 3.60 moles. Now, once you have moles, you can really convert it to anything. You can, not anything, but you can convert it to grams. So if you know moles, you can go to grams. So you just multiply by the molar mass if it ever asks you that. Here's another problem, another example. It says, how many moles of sodium sulfate are present in 25 milliliters of a 0.2 molar solution? So it wants to know how many moles again. Well, same setup. I need to change my 25 milliliters to liters. So I need to divide by 1,000. So I'm going to move my decimal 3 places to the left. So it's going to be 0.025 liters. And I'm going to multiply it by 0.12 moles per liter. So take 0.025 times 12. My liters is going to cancel out. Is 0.3. The answer would be 0.3, and it's going to be 0.30 moles of sodium sulfate, which, if you don't remember, is Na2SO4. Okay, so on to the next page. Just some more calculations, some more practice. It says 0.2 molarity of sodium carbonate was used in the last lab. How many moles were in 1 liter? Well, again, I'm trying to find moles. So if I want to go from, I actually am going to use the triangle up here. I'm going to use that instead of the diagram over to the side. So I'm going to say moles, liters, and then big M for molarity. So if I want to find how many moles, I got to take the molarity times the liters. So I'm going to take 0.2 moles per liter and multiply by 1 liter. Hopefully you guys can do the math without a calculator. That will give you 0.20 moles. And because of sig figs, it should just be 0.2. Okay, now the next question says, so we really can't weigh out 0.2 moles. So what we're going to have to do is we will have to convert moles to grams, which not too difficult. So when you got to go moles to grams, so 0.2 moles times the molar mass. So 1 mole of sodium carbonate. So let's figure this up. So sodium, the molar mass of sodium is 22.98. Multiply that by 2, plus carbon is 12, plus 16 times 3. So that gives me a molar mass of 105.96. If I can write it. So 0.2 times 105.96 will give me approximately 21 grams. Because of sig figs, you probably would round to 20, but honestly, if you're in the lab, you would just do 21 grams. That's how much you would weigh out. So what I want you to do is I want you to take a minute and I want you to try the next problem, and then I will actually do the next problem with you. But if you have 50 grams of silver nitrate were dissolved in 1 liter, what is the molarity? Okay, so problem number 2, it says if you have 50 grams of silver nitrate were dissolved in 1 liter, what is the molarity? So first you have to solve for moles. So to get moles, if you're given grams, you have 50 grams and you got to solve for moles. So grams, 50 grams divided by the molar mass of silver nitrate, which is 169.87 grams, that will give you 0.294 moles. Once you got the moles, then now you can solve for molarity. So take 0.294 moles and divide by 1 liter, and therefore you have the molarity of 0.294. Okay, next problem. What volume of water must be used to dissolve 100 grams of C6H12O6, that's glucose, to make 1.5 molar solution? So now we're trying to find volume. So if you look at the triangle, look at your triangle, in order to get volume, liters is equal to moles over molarity. Well, you don't have moles, but you do have grams. So you got to convert 100 grams to moles. So take 100 and divide by the molar mass of glucose, which is 180.18 grams. When you do the math, that should give you 0.5550 moles of glucose. Now, once you have moles, you can solve for liters, So take the moles, changes up here, and divide by molarity. So 0.5550 moles, and then divide by 1.5 molarity, or moles per liter. And I did it this way so you guys could see how moles cancels out. So 0.5550 divided by 1.5 will give you 0.37 liters. And we don't measure things, well, we do in science class, but you're more likely to measure it in milliliters. So to go from liters to milliliters, you multiply by 1,000. So that's how I get 370 milliliters. So question, what do you always find first? In this case, on this problem, you're going to find moles first. So we want to know what the molarity is. So I'm going to take 85.8 grams of sodium hydroxide of NaOH, and I am going to divide by the molar mass of sodium hydroxide. The molar mass of sodium hydroxide, I believe, is around 40, it's around 40 grams. Let me check So 22.98 plus 16 plus 1.01, that'd be, yeah, 40. So it's divided by 40 grams. So 85.8 divided by 40 will be with sig figs will be 2.14 moles. Now, that's your moles of sodium hydroxide. And then once you have your moles of sodium hydroxide, you are going to find your molarity. So you're going to take 2.14 and divide by 0.250 liters. This is moles. So that's 2.14 divided by 0.250, and you should get a molarity of 8.56 or 8.5 molarity. That's the concentration. So you have 8.5 moles per 1 liter of solution. So we'll do one more together. It says, how many grams of calcium chloride does it take to make 500 milliliters of a 6 molar solution? So it's asking you to find grams. So you're not going to find grams until you find moles. So in order to get moles, you have to take the molarity, so 6 moles per liter, and you have to multiply it by 0.500 liters. So cross out liters. So 6 times 0.500, and that should give you 3 moles of calcium chloride. And it should be 3.0 moles of calcium chloride. Now, once I have that, I can go and find my grams. So 1 mole of CaCl2 calcium weighs 40.07 plus 35.45 times 2. So you should get a molar mass of 110.97 grams. And then, so I'm going to take 3.0 times 110.97 grams. So my moles cancel out, and I should get 332 grams of calcium chloride. So you're going to practice and do homework pages, and I'll post the answers. If you have any questions, please let me know, and I'll actually continue. I'll have another part 2 to this video. Maybe, I'm not sure, but just if you have any questions, please email me.